A reinforced concrete slab is a crucial structural element, and it is used to provide flat surfaces, floors and ceilings in buildings. On the basis of reinforcements provided beam support and the ratio of the spans, slabs are generally classified into one-way slab or two-way slabs. The former is supported in two sides and the ratio of long to short span is greater than 2. However, the latter is supported on 4 sides and the ratio of long to short span is smaller than 2. Varying conditions and stipulations as for the selection of appropriate and low cost effective concrete slabs, keeping in view the type of building, architectural layout, aesthetic features, and the span length. Concrete slabs therefore are further classified into one-way joist slab, flat plane, waffle slab, hollow core slab, precast slab, slabs on grade, hotly slab, and composite slab. Well, there are many variants of slabs, and we're going to talk about of them in this video. Greetings to all the builders out there. My name is Jesus Arroyo and this is Planos Constructivos. For all those who come new to this channel, this is a place where we talk about construction, architecture, and everything related to it. So in this video we're going to talk about slabs, and also we have to study pretty much how the load is spread among the different structural elements. And the first ones are the one-way slabs on beams, and cast in situ method is used to construct one-way slabs on beams, which involves fixing of forms followed with the installation of reinforcements and finally the pouring of fresh concrete. One-way slabs on beams are most suitable for spans of 3 to 6 meters and a live load of 3 to 5 Newton per square meter. They can also be used for larger spans with relatively higher cost and higher slab deflection. Additional formwork for beams sometimes is needed, because you have to pretty much rest all the slab on those two beams. So here you go. Let's just say this is a one-way slab, and pretty much all the load is distributed like this. You pretty much have to check on the span and also the ratio of the length, and this is how it works. You have here the two beams, and let's say we have another yellow beam, and everything among them, let's call it like the purple part, is from the middle, and then the red part is for the yellow beam. All the load is distributed to this yellow beam, and the purple one goes to the green beam. Pretty much all the purple section, if you have like a floor plan, this is purple and this is red, and it goes like from the green and yellow. I know this looks awkward, but let's just say it's the best way to explain it. Also among the one-way joist slab, there's also a ribbed slab, also called here in the Mayan Riviera vigueta y bovedilla, because the vigueta acts pretty much as a beam among the slab. I'm going to show you on another diagram, and pretty much it consists of a floor slab, usually to 50 to 100 meter thick, but it depends on how long the span is, so you can pretty much distribute the loads. And it's supported by reinforced concrete ribs or joists. The ribs are usually tapered and are uniformly spaced at distances that do not exceed about 75 centimeters, and are supported on grinders that rest on columns or beams. A one-way joist concrete slab is suitable for spans from 6 to 9, especially is like if it's precast concrete. But here in Mexico, especially in the Mayan Riviera, we use let's say spans, shorter spans. Let's just say it from 2 meters to 5 is pretty much what the prefab beams are made. And we use styroforms styrofoam formwork for you know, pretty much like in the video on the back of me. So because of the deep ribs, the concrete and steel quantities are relatively low, but expensive formwork is needed. Or sometimes it doesn't have to be, you know, styrofoam is not like that expensive here in Mexico, and you can pretty much leave it on the slab and use it for later. So here we have it. This is the the plan view, you know, or the floor plan view, and we have the columns here on yellow, and we're also gonna put them on the section view. This is the column, and also you have like the beams, the main beams. Let's say I'm gonna put it on green actually, so you can pretty much understand what's going on in here. You have the main beams that are in here, and also you have the ribs that will go on purple, and all these ribs rest on the main beam and the main beams that go, you know, all the way actually from here to here. And these are the beams on the section view. It doesn't have to go, you know, they don't have to go like this conic shape. They could go squared actually. Here in Mexico they do it in a different view. And it works more like a, you know, you have the ribs, which are little beams, and when you cast concrete, you know, all the concrete falls into these ribs. This pretty much work like little bolts, you know. This is a formwork that is also integrated into the concrete. They pretty much get embedded once you cast the concrete on the slab. But there are, you know, pretty much in Mexico we have two of them. You know, one little bolt is made of concrete, precast concrete, and the other one is made of styrofoam. So it's, you know, it's pretty much lighter, and it's, let's say, it has more qualities when it comes to the sun and heat and sealant properties, pretty much. Now another one is the waffle slab, and this is the typical reinforced concrete slab that contains square grids with deep sides. Waffle slabs in construction process includes fixing forms, placing of pots, and shuttering, installation of reinforcement between pots, installation of steel mesh on top of pots, and pouring of concrete. For me, this is my personal favorite because it's the one that has the more resistance to it, and it also, you know, it works like a big. The entire slab works pretty much like a beam, so it goes two ways, and also it has more resistance, and it has like let's say heating properties. Actually there's like sealing properties, because it also contains, you know, a styrofoam formwork that it goes inside. So if you want to, let's say if the sun really heats the slab, it can, you know, protect you from that, so it doesn't get really hot inside the house. So you've seen it on the video behind me, but now let's see it on, you know, pretty much a floor plan and also section plan. And pretty much you have the crown here, which is a section that you pretty much cast the concrete in the whole section, which corresponds to this section over here. And there are also the column that I'm gonna mark in purple. You see it on the floor plan, but here is the column, and all the load is gonna come from this side to pretty much here. But also you have the ribs. The ribs are marked on green and go on both ways. Pretty much what you gotta watch for this kind of slab is for the let's say for the kind of styrofoam or pretty much cast in situ, you know, formwork that you're gonna have, which is gonna, I'm gonna write it on red. This over here, it doesn't have to go on styrofoam or anything like that. You could pretty much use any material as long as it respects, you know, the measurements or you know, pretty much the measurements of these ribs over here. And it's called waffle slab because it does look like a waffle. So this is for me the best one. It works better, you know, for loads, higher loads, or also, you know, for for isolating your house or anything like that, especially here in Mexico where the sun heats really hot. Now there's another one, it's called flat plate, and flat plates can be constructed as one-way or two-way slabs, and it is directly supported by columns or walls. It is easy to construct and requires simple formworks. Flat plates are most suitable for spans of 6 to 8 meters and live loads between 3 and 5 kilonewtons per square meter. Added to that, the range of spans for pre-stressed flat plates is between 8 to 12 meters, and it can also be constructed as post-tension slabs. The advantages of adopting flat plates include low-cost formwork, post-flat ceilings, and faster construction because flat plates have low shear capacity and relatively low stiffness, which may cause noticeable deflection. I do not recommend, in my experience, I do not recommend so much the flat slabs, especially if you have a place where there's a lot of earthquakes, such as Mexico City and places like that. If you are in Europe and you don't have a lot of earthquakes, then it could be awesome because and also if you have don't be afraid of using a flat slab. If you have small spans, if every span is about 3 to 4 meters, it's okay, it can work, But if it's a longer span of, longer than 5 meters, then pretty much don't use it if you are in a seismic zone, where there's a lot of earthquakes happening. And it is because this is typically a reinforced slab supported directly by columns or caps without the use of beams. This type of slab is generally easy to construct and requires very little formwork, and the loads are directly transferred to the columns. Flat slabs are most suitable for spans, as I just told you, and they need more formwork than flat plates, especially for column capitals. I don't use it here in Mexico a lot, the flat slab with column capitals, but I just told you because, pretty much if this is worldwide, you can maybe using one of those. Also, bear in mind that you can use beams on those flat slabs and pretty much make it as a two-way slab on beams. And the construct of this type of slab is similar to the one-way slab on beams, but it might need more formwork since two-way slabs are supported on all the sides. Also, it can rest, on walls, structural walls that can, don't use it on sheetrock walls or, any type of, styrofoam walls. So you gotta check on those first. Now another one is a hollow core slab, and it is a type of precast slab through which cores are run. Not only do these cores decline the slab self-weight, but it increases structural efficiency, but also acts as service ducts. It is suitable for cases where fast construction are desired. There is no restriction of the span of the hollow core slab units, and their standard width is about 120 millimeters in depth and ranges from 110 millimeters to 400 millimeters. The slab units are commonly installed between beams using cranes, and the gaps between units are filled with screeds. It has been observed that hollow core slabs can support about 2.5 kilograms newtons per square meter over a 16-meter span. It is suitable for cases, offices, retail stores, pretty much parking lot developments, and especially if you're gonna build, like a big building, then use it. If you're gonna build, like small houses, not very convenient because you have to use a crane. And cranes here, especially here in Mexico, are very expensive to use unless you own it. But pretty much if you're gonna rent one, it's gonna cost you a lot. So I do not recommend it when it's a small house or a small building. If it's a larger building and you have the crane and pretty much your budget allows it to it, then go ahead and use it because it's gonna save you a lot of time, and also it's very convenient and you don't have to spend a lot of time on doing this. Now there's a new one of slab. I personally haven't used it, but it calls my attention because it's pretty much constructed by placing plastic bubbles, which are prefabricated, and then the reinforcement is then placed between another plastic bubbles, and finally fresh concrete is poured. The plastic bubbles pretty much replace the ineffective concrete at the center of the slab. Also, the bubble deck slab reduces weight, increases strength, larger spans can be provided, fewer columns needed, no beams or ribs under the ceiling are required. Consequently, not only does it decline the total cost of construction, but it also environmentally friendly since it reduces the amount of concrete. It pretty much works kinda and like let's say like the waffle slab. And if you see the the section of it, now another one is the composite slab. Here in Mexico we call it losa acero because it has pretty much it would be translated as steel slab. And it's commonly constructed from reinforcement concrete cast on the top of the profile of pretty much as a steel decking profile, and the decking acts as formwork and working area during the construction phase. It is also acts as a thermal reinforcement during service life of the slab. For steel decking thickness between pretty much about 50 to 60 millimeters, the span of the slab can reach up to 3 meters. However, if the steel decking thickness is increased up to 80 millimeters, a slab with a span of 4.5 meters can be constructed. Yeah, this pretty much what I've used them is pretty much in the industry, in steel structure industry. I have another videos in Spanish, but if you want to check it out, you can go ahead and review my old videos. I'll start to translate those in Spanish as soon as I can. So let's talk about the other slabs. Now let's say there's another genre of slabs. There are also prefab or precast slabs, and concrete slabs are casted and cured in manufacturing plants and then delivered to the construction site to be erected. The most outstanding advantage of the preparation of slabs in manufacturing plants is the increase in efficiency and higher quality control, which might not be achieved on the site. The most common used precast slabs are the channel and the double T types. They can be used for the spans up to 15 meters. The double T slabs vary in size and spans up to 15 meters have been used. The tongue and groove panel could vary in size based in the design requirement. When they are placed in tongue of one panel, it is placed inside the groove of adjacent panel. Pretty much works like the hollow slab. And it's also the same, pretty much if you're gonna build a small house, I wouldn't recommend it, but if you're gonna build a big building, then I would advise you to go for that kind of slab, since it's like pretty much time efficient and also time saving. Also, there are another slabs which happen to be on the ground, and it's the simple type of a slab on grade, which is a composite of stiffening beams constructed from concrete around perimeter of the slab and has a slab thickness, or it depends, of 100 millimeters, and it is suitable for stable ground, which is most composed of sand and rock and not influenced by moisture and soils that undergo slight movement due to moisture. Also, in the ground, it goes like the stiffened raft slab, and is similar to slab on the ground apart from stiffening beams, which are set in the channels through the middle of the slab. Consequently, it creates a kind of supporting grid of concrete on the base of the slab soil, which moderate high amount and severe momentum due to the moisture. This is pretty much a slab on the ground, but you have to pretty much excavate a little you know, with a machine, or like little ribs on the for the slab. And this is it. Thank you very much for watching this video. Thank you for all your likes and subscription. And if you like more videos like this, don't forget to comment, and see you around.